we're going to learn the acid-base neutralization reaction. So in aqueous solution, neutralization is a reaction of hydrogen and hydroxide ions to form water molecules. So you're taking an acid and you're taking a base and you're going to mix them and you are going to neutralize them. So when you do that, water is going to be produced. So water is always one of the products, and you're also going to create a salt. A salt is from the cation from the base and an anion from the acid, and it's basically a double replacement reaction. So remember that cations are positive and they always go first in the compound. Cations always go first. Then anions are negatives and they always go second. Okay, so this is how it works. You're going to take an acid. You know you have an acid because it starts with the letter H. And an acid always is attached to an anion here. A base is always attached to the OH. That's how you know it's a base. But it's always attached to a cation here. Now, this H and this OH creates water, and then the anion and cation will produce the salt. Okay, so we're going to do an example to help you understand this. So here we go. Okay, so you have HCl and magnesium hydroxide. So you are going to neutralize stomach acid, HCl, with milk of magnesia, magnesium hydroxide. So let's start. When you look at this example, you're going to identify that this is your acid and that this is your base, because the H and the OH. Now, they are going to separate, okay? So they are all going to separate into their parts. So hydrogen and this hydroxide, so the H from the water, right, and the OH from the base are going to come together to make water. That one's pretty simple. Now, here comes the tricky part, is making your salt. So your salt is whatever's left over. So you have this chlorine here and you have this magnesium. Now remember, you're going to have to use the periodic table to understand the charges. So let's do a quick recap. You know by now that the top, this is going to be +1. You're going to lose an electron. You're going to lose 2 electrons. You're going to lose 3 electrons. Does a skip, and it goes gain 3 electrons, gain 2 electrons, gain 1 electrons, and then nothing here. So once again, it should be really easy because it's a 1, 2, 3, 3, 2, 1. Okay? 1, 2, 3, 3, 2, 1. So when you look at your leftover elements here, you're going to have to put charges on them. So they're already there, but just so that we can practice, we see that magnesium is right here. If you look, it's a +2 charge. So I'm going to make a note here. Magnesium is +2. So this is our cation because it's positive. And then you're going to look up chlorine, which is here. It's a -1 charge, right? So then you're going to do chlorine and you're going to do -1. This is your anion because it's negative. Okay, so now you're going to cancel out the charges. Okay, so you have a +2 and a -1. So how many of each do you need to cancel out the charges? For every 1 magnesium, I need 2 chlorines, and that is what you see right here, MgCl2. Once you predict the products, then you have to balance the equation, okay? The way that we balance the equation is, I'm always going to say to balance the salt and then count the leftover H's. And I'll show that in the next example because this one is already balanced. So let's do this next example together. Okay, so here you have a KOH and a H2CO3. Okay, hopefully you know that this is your acid, so you're going to put an A here because this is your acid. Okay, you're going to label it. Then you notice that this is your base because it has an OH, so you put a B for base. You always know one of the products is going to be water, H2O. 2O. So you're going to put W here for water. So the H from your acid, the OH from your base is going to create water. So the question is, what is left over? What's left over is this letter K and this CO3. Okay, so now off to the side here, okay, my salt, I need the K and CO3. So K, according to my periodic table here, is right there. It has a positive 1 charge. So I am going to put K with a positive 1 as a side note for now. Okay, next you have a leftover CO3. That is a polyatomic, so you're going to look at a list over here. CO3 is right here. That is carbonate, so it's CO3 with a negative 2 charge. So you're going to write CO3 with a negative 2 charge. Now, if you have a positive 1 and a negative 2, then how many of each do you need for the charges to cancel out? You are going to need 2 Ks, 2 potassiums for every 1 carbonate. If it makes you comfortable, you can always put parentheses like this. And this, you're going to label S because this is your salt. Okay, now you have these blanks because you need to balance the equation. So now this is my piece of advice right here. Number 1, you always balance the salt first. Okay, so you're going to look at your salt, that's right here. You have 2 potassiums, 2 letter Ks. So then you're going to look at this letter K and you're like, okay, I'm going to need 2 of these, okay, because I have 2 over there. And then you're looking at carbonate, CO3. I have 1 carbonate here. I have 1 carbonate over here, so I'm good. Okay, after that, the second step is you are going to count all your leftover H's. Okay, these are your hydrogens. Okay, so what do I mean by that? You are going to count all your H's on this left-hand side. So this 2 over here on the left, okay, you have 2 H's here and you have 2 H's there. So you have a total of 4, okay, 4 H's on the left-hand side. Here you only have 2 on the right-hand side. So what times 2 can get us to a total of 4? 2. So now you have 4 H's on the left and 4 H's on the right. So now we are all balanced together. If you would like, you could always put the ones, if it bothers you that it's blank. You can either leave it blank or put some ones. So let's do one more example down here. Okay, so you look at the first compound, which is HBr, and hopefully you spot this is your acid because of the H in front. Then you have a compound AlOH, aluminum hydroxide. You see that OH, so you know that this is a base. The H and the OH, H from your acid, OH from your base, is always going to create water. So W for water. And now we have to look at our salt. Okay, so what is left over? I have aluminum and I have a bromine. So you're going to look over here. Aluminum is here, which is a positive 3. So remember, cations always go first. So aluminum is positive 3. And then I have a bromine, and bromine's here. That's a negative 1. So here I'm going to write bromine with a negative 1. Remember, cations always go first. So you ask yourself, how many of each do I need to cancel out the charges? And so I need, for every 1 aluminum, I need 3 bromines. And this is S for salt. Now that you have done this, you are going to follow the balancing order. You're always going to balance your salt first. So look at your salt. I have 1 aluminum on the right. I only need 1 aluminum on the left. So my aluminums are balanced. Now check out your bromines. I have 3 bromines on my right. I only have 1 bromine here. So I need 3. So I'm going to put a 3 right here. Now that I have balanced my salt, I'm going to count my H's on the left-hand side. So I have 3 H's here, and I have 3 H's there. So I have a total of 6 H's. Okay, here I have only 2 H's, so what times 2 can get me to 6? Answer is 3. 3 times 2 can get me to 6 H's, so now everything is equal. So now you can predict the products and you can balance the equation. If it bothers you that this does not have a 1, you can always throw a 1 right there. All right, good luck on your practice.